My name is Edmund. All right, I'm a faculty in engineering cluster with SIT. All right, and then my colleague there is Michael. All right, he is also managing the program and also teaching in the program, but he's representing Newcastle University. So the title, Mechanical Design and Manufacturing Engineering, or MDME for short, tells us that we focus in our core curriculum in mechanical engineering. But at the end of the day, we need to go into a particular specific area for our graduates to work in, and that will be in the manufacturing sector. So I'll explain more a little bit about that, how it all integrates and gels together for the degree course. And another thing you notice at the bottom here is the logos for Engineering Council as an accredited degree. So this is a recognized degree internationally. So if you go to the Engineering Council, this Engineering Council is based in UK, right? You search our degree program title, you'll see it listed there, that it is accredited. True Institution of Mechanical Engineers, also UK, all right? As we are a joint degree program, all right? It's a 3-year British degree with the Singapore flavor and context there. So after 3 years, you graduate with a bachelor's with honors degree. What we train here is to be very strong in managing high-level skills like doing robotics, doing data analysis, how to make sure that there is high efficiency in our production line. All right. So nowadays and also a lot of the manufacturing plants you see today, especially advanced one, all digitalized, very clean factory shop floor, and everything is very systematic and organized. And Singapore itself is a country with strong manufacturing focus. If you look at the country's GDP here, every year is more than 20% gross domestic product. So our degree program, MDME, focus on 3 pillars of engineering knowledge. 3 M's in particular: mechanical, mechatronics, and manufacturing. So these 3 M's allow you to gain skills and knowledge that are able to contribute to the manufacturing sector, which I'll explain more later on. And we also have one specialization dealing in electronics industry, specifically microelectronics, which in other words, semiconductor industry. So we have a particular specialization in year 2 to year 3. If you want to go embark on this course, you can also specialize in that area as well. The good thing about this program is not a traditional degree course. It's not mechanical engineering. All right, we have another program, mechanical engineering, which is more general. All right, you see planes there, you see what I call it, vehicles. All right, ours is a little bit more diverse in the sense that we are looking at the process at the core. All right, we want to optimize the process at the core, so we need industrial skills. So because we are not a traditional university, we give you or inculcate in you in the education practical skills, including things like lean manufacturing and Six Sigma. All right, how to reduce waste, how to make a process efficient and optimized, right, with minimum amount of manpower, and of course now with digitalization of the systems, all right, you can actually do all of this online and in a very efficient, productive manner. All right, you don't usually get this sort of modules or courses through a university degree, but we offer this because it's a demand in the industry. Rather than only after you graduate, only you take these courses, we already embed these courses in the program. So when you graduate, you go work in the industry, you hit the ground running, straight away you can contribute already. You don't need to go for further training for this sort of skills. And also, of course, we have our internship program, which is known as Integrated Work Study, or IWSP. This is a duration of around 8 months. You'll be working full-time in the manufacturing sector or any engineering area. It can be locally or regionally, right? We're also exploring internationally. We have students working in Vietnam, Cambodia. What we teach in our program is from the basic fundamental skills all the way to high-level skills, so you don't miss out on anything. All right? So you get the full course. You're from A levels, also you can join our program. You start from first year and gain those skills from the beginning. Okay? And these are our graduate job prospects. Very, very diverse. Engineer, of course, in manufacturing sector. You can also be a general mechanical engineer, industrial engineer, right? In automation, in robotics. You can go into quality management, quality assurance, project management, all right? product design. Okay, so as I said before, you focus on 3M, all right? Mechanical engineering, these are the modules, examples of modules that you will learn. You need to have maths. You need to know how to do drawing. Drawing means drawing designs, all right? Professional engine drawings with right dimensions, tolerances, how to do the manufacturing and assembly process, details about the materials. Then you need to know about statics and dynamics. How do things work when it's stationary or when it's moving? How they behave, all right, with the material properties embedded, mechanics there, all right? How to design it in mechanical systems. How to use things like thermal fluids, because a lot of machines on the factory shop floor, they may operate based on air, pneumatics, or oil, or fluid, hydraulics, all right? So you need to know how this works, all right? Fluid dynamics, also thermodynamic cycles and heat transfer. These are core mechanical engineering knowledge. And also how to do simulation and modeling. Nowadays, everything needs to be simulated first before you deploy, all right? On a factory shop floor or do any design or prototyping. So good to do everything on a computer, get it right first before you do the real thing in terms of fabrication and operation. Then the second M is on mechatronics. So mechatronics is a combination of both mechanical principles and electronic principles. So it's a merger of two very large branch or disciplines of engineering. So you need to know the link, all right? Knowing how things work mechanically is not enough because you need the electronics part to get it to work also, to control it, all right? To tell it what to do. So you need to know programming, how to program for a device to work, right? You'll learn Python programming, open source language, all right? Used in a lot of industries. You can do a lot of things there, all right? How to operate electronic circuits and the digital electronics involved, electrical principles, electromechanical systems to find out how they work together, how drive systems work, what actually causes a machine to go forward, industrial control systems, what are the inputs to put into a system, and then what are the outputs coming out right from a transfer function. Then, interestingly, towards the end of the program, you also learn about automation. All right, automation using robotics, all right, and how to analyze data. So data science is also involved. So ICT component is also there in our program because if you are doing manufacturing, there's manufacturing data, and you need to find out how to actually process and then analyze the data so that your production becomes more efficient. What are the areas that are having a lot of waste? Then you want to remove those wastes so that it become more efficient. And then Internet of Things, connectivity of everything. Everything is now online, all right? How do you connect? How to write an app, all right, to control a mechanical system or device. You also learn how to use that. You work with Arduino systems, do small little projects, and get that application to work for real problem or solve a real problem. And then as I mentioned before, robotics, all right, how to control either robotic devices or mobile robots that move, something like robots that move on a factory shop floor. And then finally, all this culminates into our last M, which is manufacturing, all right? You need to know how materials are being used for design and manufacturing, all right? How the advanced principles involved there for manufacturing, because you need to design your products based on the materials available. Sustainability also very important there, all right? You need to make sure that the resources used are consumed properly, all right, in the production process. And as mentioned before, optimizing processes through lean manufacturing at Six Sigma principles with the least amount of time to come out with the lowest turnaround time. And digital manufacturing and smart manufacturing system is what you also see at our booth, right? How to make sure everything is connected, digitalized, and can be controlled and monitored, all right, to a very organized and structured manner. So these are the 3 M's, all right, which will give you the core skills to work in the engineering sector, specifically in manufacturing. And of course, at the bottom here is also foundational skills that you will also learn, professional engineering skills in areas of project management, all right? How to do design in terms of thinking forward in design innovation, design thinking, career skills, how to communicate properly and professionally, either written form or orally, do a proper presentation, finance, law, and standards for engineer, this is also necessary. You need to know what is the standard, for example, safety standards, quality assurance standards. You cannot just design anything without any proper guidance or standard. You need to know this on a local context, critical thinking, how to analyze data properly, how to communicate those ideas properly, and finally, digital competency essentials, digital skills. All right. So this is something core that you also need to learn because everything nowadays are digitalized. Okay, so now I'll just pass over and hand over to Prof. Michael to share a little bit more about Newcastle University.
Besides the practice engineering, we also do a lot of research in Newcastle, and the research excellence towards design and manufacturing. Okay, Newcastle University core, okay, Center of Research, okay, is in energy. We also have the mobility and transport. Okay, one of my colleagues works with A-Star and transport systems here towards inclusive and healthier non-zero carbon. Now, this additive manufacturing is a very important thing. In Singapore, you have the ARTC, which does a lot of research in additive manufacturing, non-metal as well as metal. We have a gear technology design unit in Newcastle. They specialize in designing gears for heavy transport vehicles. So we were in UK. We are part of the National Metrology Center, where they look at gears specifications, measurements, and tolerances. Okay, and of course, many of us have to do stress analysis. Whenever you design any part, you make sure that it can withstand the load that you design for. Okay, and you design it, yes. So we go into SolidWorks and analyze it. So the gear design unit does that. Okay. And you can see that they're quite a complicated meshing gears for ships and heavy transports. This is the gathering of the students in the overseas immersion program. They do a inter-programs project where marine engineering, chemical engineering, electrical engineering, MDME engineering, MDME, the students will work together in a project, and at the end of the day, they'll do their presentation. These are the labs, okay, in the UK, and this is a visit to the Nissan factory in Sunderland, which is not so far from Newcastle, makes electric vehicle Leaf, I think. It's called the Leaf for Nissan. And on top this corner here, okay, you find the students learning to do production assembly, okay? Assembling a cab, okay? And first they give you a thing to do, and if you don't have a proper procedure, they find that it's very hard to assemble it properly and quickly. Then they show you the Caterpillar way of, it was called Caterpillar plant. They show you the Caterpillar way of doing production, scheduling, and assembling. And the student find that, oh, it's much faster to produce, okay, the parts and so forth, okay? Okay,
so now I'll just showcase a few of our lab facilities, all right? So you see these are learning resources. We have the thermofluids lab. So as I mentioned before, you need to know about fluid dynamics, how hydraulics and pneumatics work. Right? So you need those to learn those principles. Electronics, all right, because electronics is tied to how to control or move mechanical devices. Robotics, automated guided vehicles for mobile transportation of goods and services, either within a factory line or in a service line. Collaborative robot that work closely with humans or human operators. Workshop to do machining and additive manufacturing, 3D printers. We have a whole line of 3D printers for you to do prototyping work and quick fabrication. Our showpiece, our showcase lab is the advanced manufacturing lab, okay, because our program is focused in this area, and that is our full production line, which is Industry 4.0 compliant. So this is our learning factory. There are areas that you can consider part of your education, the program. How to do simulation, and I'm not sure whether you're familiar with a digital twin, all right, something that you can see on a computer, all right, the entire production process there, run it, and then if it's optimized already, then only you put it to practice on the real machine, okay? Do computer-aided design for products, and then manufacturing execution system is like the controller for the entire factory, so you need to know how to actually like get the raw materials. Is it the supply there is enough? Put it through the line and then control how things are being moved down the line and being assembled and stored at the end. There's real-time data management, and then also how to analyze the performance of the machine and see where are areas that can be further improved in terms of efficiency. And then in the areas of robotics and automation, you learn how to do programming and control of these devices, both industrial static robots to mobile robots, and also learn how to use things like machine learning for data analytics, right? To train the system to actually do interpretation of data, manufacturing data. So that's just a quick overview, right, of the learning factory, which you will be exposed to at the final year of the program if you do undertake this course.